This module deals with the intuitions that are behind Capm, or the Capital Asset Pricing module.
The capital asset pricing model is fundamentally about pricing assets in a market context. And within that market context, the price of the underlying assets equilibrate, and that's what results in the capital asset pricing model. If you want more about the intuitions behind Capm, look at Chapter 4 and Chapter 5 of our reading.
An intuition can be gained by looking at the formula for determining a return to asset. Um, this is the formula that you see there is the one we used at week one. Return to an asset is composed of two portions. In the red, we have the capital gain plus the dividend, and then we divide that all by the price at the beginning of the period to come up with the rate of return. In a market, both those prices are represent the discounted cash flows, in the future, discounted to the current time point. So if we have changes in the cash flows, we will have changes in the price that will then lead to a capital gain. What the market does is sets the price E, or the price at the end of the period. Actually, it's setting the price at all the time during the process. But when we come to the end of the period, we come up with that price at the end of the period. That's set by the market. And again, what the market will be doing is using some representation of future discounted cash flows and coming up with that price at the ending of the period. Well, if that price at the ending of the period is set by the market, that fundamentally influences return on asset, or the rate of return on that asset. And so the market's influencing the price and also the rate of return. Let's go through a couple of examples here. And first, let's take the case in which expected returns in the future increase. So now we're looking 1 year in the future, 6 months in the future, 2 years in the future. We believe that a firm has had its expected returns increase for whatever reason. It could be that it introduced a new product, iPhone, iPad, for Apple, for example, who's likely to have positive impacts on returns in the future. If we see that the value of that firm has increased because its discounted cash flows in the future, or excuse me, its future cash flows have increased, we've discounted those back to the future, value has increased, we would then expect that to lead to price increases. Everybody, or most of the market participants, see the value increase, so its price increases, and the rate of return in the current period would increase as well. Now, let's take another example and say if a firm has its risk in the future decrease. For whatever reason, the riskiness of that firm has declined. A major competitor has exited the market. That would cause that firm to have more stable returns because its competitor is left. If that's the case, we would reduce the discount rate because, again, discount rate reflects risk. If risk has decreased, we would lower the discount rate. That would lead to higher expected values for that firm. The market again would see those higher expected values, bid that into the prices, and that would lead again to the current rate of return increasing. When looking at the financial press, what you often see is that they're concerned about above events. What's happening to future returns and risk for the firm, and why they're doing it is so that they can project the price in the future. We used here in these two examples items that cause the rate of return during the current period to increase. You could reverse it. If expected returns in the future decrease, First example, value decreases. Value decreases, the market would bid that into a decreased price, and the rate of return during the current period would also decrease. Similarly, if risk in the future decreases, you would expect the discount rate to increase, values to decrease. The market would see that, bid it into the price, then leading to the rate of return during the current period to decrease. The previous slides provided intuitions between the linkages between prices and returns in a market. That doesn't get us to the point of deriving the capital asset pricing model, Capm, and I'm not going to do that. If you want to see more intuition behind the derivation of Capm, then I would suggest you go to Chapter 5 of an Introduction to Investment Theory. This isn't in our textbook, but you see the linkage there, and it does provide a bit of the intuition behind how you get from those observations about the market, along with some fairly restrictive assumptions about how the market works, to the point where you can derive beta and the capital asset pricing model. Excuse me. So, if you want to see the intuition behind beta, go to Chapter 5. This is written by Goetzman, who's at Harvard, and a very good chapter. And again, to derive the capital asset pricing model requires quite a bit of math. And if you want to look at the math, even go back to the Sharp and Littner pieces that we cited earlier in this module. There are three results of Capm that we're going to make use of here. First is that when there's a risk-free asset and idealized market conditions, and no frictions within that market, same expectations on the part of everybody wants to hold the same portfolio. It happens, number two, that everyone wants to hold the market portfolio, and that would be, for example, you can think of that as a Dow Jones Industrial Average Standard & Poor's 500 index fund, or ETF. And the results of Capm are that the weights on that market portfolio equal the market cap of each stock in that portfolio. A final result is that beta is the measure of risk, and we're going to talk more in detail about beta in our next module. 2 points about Capm. First, Capm provides much of the rationale for holding broad index mutual funds and ETFs. One of the advices that you will see given to people is hold an index fund that mimics the broader market, S&P 500 for example, and don't worry about picking individual stocks. Capital asset pricing model provides much of the rationale for holding broad-based indexes. Second is that market efficiency is underlying capital asset pricing model. Capm is based on market efficiency, and market efficiency is an important piece in understanding and evaluating financial markets. Market efficiency is a somewhat controversial topic. Most academic studies point to a large degree in which markets are efficient, i.e., in other words, the market prices and returns capture all the information there exists about returns and prices to those assets. Other people disagree and point to specific cases in which market efficiency supposedly did not hold. Whether or not you believe or don't believe in market efficiency totally, it comes at some peril to ignore it. In particular, if you believe something's a good investment and that you're going to purchase that asset, someone else has to have a different opinion. And again, coming back to the market, particularly on stocks and bonds where you're buying those typically on secondary markets where somebody else is holding them, if you believe something's a good investment and you're going to buy it, someone else has to be giving up, and they have to believe for whatever reason that it no longer fits their portfolio, or it's no longer their in their interest to hold it. It's those combinations of forces that come together that one should be aware of when they're making market investments. you believe something's a good investment, to get it, somebody else has to be willing to generally give it up.